So hello everybody, this is my video on relative local extrema or local mins and maxes. I know you're going to miss having class on Wednesday, but I'm here, so it'll be okay. Hopefully you guys understood it today. I know it was pretty confusing, we went pretty quickly, so maybe if we do it a little bit more times. This one involves trig functions, and this is why we played that crazy steal the bacon game during the potluck. So we're doing the exact same process, but now we're going to do it with some trig functions. So this one says state increasing and decreasing, find the x-coordinates of all the extrema, and then identify each as a local max or min. Alright, so the very first step, if you remember, is to what? Yeah, I'm going to take the derivative. So derivative of f of x is going to be the derivative of cosine, which is negative sign. And some of you might be confused, what do I do with this sine squared? And rightfully so, and some of you really hate trig, but I'm telling you, y'all can do it. Okay. What I'm going to do is, instead of saying the derivative of sine squared x, I'm going to rewrite this so it'll be a little easier to comprehend. I'm going to call this sine x parentheses squared, because this means the exact same thing as that 2 in the middle. So this one and this one mean the exact same thing. Okay. Now how do I take a derivative like this? Which rule am I going to use? Yeah, that's right. I'm going to use the chain rule. So I'll push the 2 out in front. I'm going to get a 1 exponent, so I'm just going to leave it blank. I know it takes a long time for me to write this. And I multiply by what? Yeah, the derivative of the inside. And the derivative of the inside is going to be cosine. Yay, this is fun. Well, anyway, it's cosine. Okay, so I'm going to put that here. So this is going to be plus 2 sine x cosine x. Okay, so far? Okay, what was my next step? Yeah, I'm going to set it equal to 0. So I think it might be actually easier for me to type this. So negative sine x plus 2 sine x, here, 2 sine x cosine x equals 0. What was my step after that? Do y'all remember? Yeah, what I'm going to do is I'm going to factor this. What do this term and this term have in common that I could factor out of both of them? It's a sine. So, well, it's not a sine, but sine is my common factor. So just to make things nice and neat, I'm going to factor out a negative sine x, which would give me which would factor out a 1 minus, and I'll have a 2 cosine x on the inside. Okay, so now we factored, now we have 2 terms that multiply to give me 0. So I'm going to set 2 things equal to 0. I'm going to set the one on the outside, and the first thing being multiplied, and the second factor, well, I'll take each factor and set them equal to 0. So either negative sine x equals 0, or 1 minus 2 cosine x equals 0. Alright, now this is where most of you get confused. Okay, now I'm looking for what values, or just like our game, what rating measures the sine equals 0. Okay, sine equals 0, and in most books, or what they really care about, is the only interval is from 0 to pi. Okay, from 0 to pi. Where does this equal 0? Okay. If I look at my unit circle, if I look back at my unit circle, and let's find out where sine equals 0. Okay. And again, you guys should be comfortable enough where you shouldn't have to look at the unit circle anymore. So we'll practice first. But here we go. We have the unit circle, and again, all I care about is the values is from 0 to pi. Okay. Where do you see? Remember, cosine is the x value, sine is the y value. Where do you see on this unit circle where my sine is equal to 0? Which radians measures? I see one right here, which is 0 pi, and I see another one over here, which is pi. So I'm going to go back to my problem, and x, or my critical numbers, are going to be pi. I don't have a pi button, so I'm just going to call it p, and negative pi. Okay, my 2 values in which, my 2 radian measures where sine equals 0. Okay. I'll move on to the next one. This case, I'm sort of doing the same thing, except for, on the left side I had sine by itself, but on the right side I don't have cosine by itself. So the first thing I'm going to do is I'm going to want to get cosine x by itself first. So first I'm going to subtract 1 from both sides. Okay, and then I will divide both sides by -2. So do you see how I get cosine x equals half? So now, same thing, just like our game. At what radian measure is the cosine value a half? So look at my unit circle. Again, all I care about is from 0 to pi. There's some over here. But where between 0 and pi do I have a cosine value, which is the x-coordinate, equal to half? I see 1 right here, and that's it. That's the only place where I see a radian measure where I have a cosine of half, and that's at pi over 3. So I'm going to go back to my problem. My other critical formula is pi over 3. Okay. How about this? So you guys don't get confused or wonder where this p comes from, I'll call it pi. So I have 3 critical numbers. Yeah? So now I did step 1, I took the derivative. Step 2, I set it equals 0. And step 3, I found my 3 critical numbers. What did I do after I found the critical numbers? Yeah, I did this number line. And some of you might be confused, where do things sit on the number line? You could use the unit circle as your guide. Whereas remember at the unit circle, you start here and move counterclockwise, like 0, 90, 180. The smallest of the 3 critical numbers is 0, followed by pi over 3, and then next by pi. So let's put this on my, I'll put this on my number line. 0, pi over 3, and pi. Now what might be confusing for y'all is, what numbers should I test? Okay. Remember when we did like regular numbers, like if I had 0, normally I would say -1 and +1. But when I'm doing trigonometric functions, 1 and -1 are not the easiest things to test, because on my unit circle there is no 1, -1. Okay. What I'm going to do is I'm going to pick values less than and greater than 0, or less than greater than pi over 3, that are at these 4 coordinates. Whether they're here, or here, or here, or here. The best case scenario is to use these because I have these nice clean numbers 0 or 1. Okay? And sometimes you won't be able to use them, so we're going to have to play around and see what I have to test. But ideally, okay, I want to test these 4 nice and easy points because they're all 0 and 1. There's no fraction, there's no square roots. So your goal is to get 0 and -1, or at these 4 points. Okay? So looking back at my number line, what's a number less than 0 that allows me to get one of those 4 points? So look at my unit circle, here's 0. I'm looking for a number that's less than that. So do you see at 3 pi over 2 is less than, or how about this? Negative pi over 2 is less than 0. So I'm going to put negative pi over 2. I know it's confusing, we'll practice in class. And then between 0 and pi over 3. And you see in my unit circle, there's none of those nice clean numbers is between 0 and pi over 3. Yeah? So I'm going to take the next best one. Let's test pi over 4. Okay, you can pick pi over 4, you can pick pi over 6, but do you see how those two are in between 0 and pi over 3? And then I need a number between pi over 3 and pi. This one's sort of easy. Here's pi over 3. Here's pi. The nicest, cleanest number between pi over 3 and pi is going to be this one right here, pi over 2. And lastly, a number bigger than pi. Again, I'll try to find one of these numbers. I'm looking at here's pi. A number bigger than pi, that's one of the 4. It's actually cut off by the video, or by this window, so let me scroll down a bit. So the next number that's bigger than pi, that's a nice clean number, is 3 pi over 2. I keep switching to Brent's message to me. 3 pi over 2. Oh, 3 pi over 2. Okay. Now that I have my 4 numbers I'm going to test, remember I'm going to plug them in back into my derivative, which was this one. Right? This is my original derivative one. And now I'm going to start plugging in some numbers. Okay. First what I'm going to do is I'm going to plug in negative pi over 2. Okay. When I plug in negative pi over 2, I get negative sine pi over 2 times 1 minus 2 cosine pi over 2. So this is why it's very important that you don't rely on the unit circle, because it's going to slow you down. Sine pi over 2, if you forget, you can always refer to the unit circle, but sine pi over 2 is going to be 1, okay, which is what you want, because you want those nice clean numbers. Is 1, which will be negative 1, times, so it's negative 1. So the first one is negative. And when I apply a pi over 2 here, cosine pi over 2 is 0. 1 minus 0 is 1. So I have a negative 1. Start again. Cosine pi over 2 is 0. 2 times 0 is 0. I get 1 minus 0. So this is what? So this is positive. So if I get a negative and positive, this whole zone, this whole zone is negative. Okay. Testing pi over 4. Sine of pi over 4 is negative radical 2 over 2. And then here, cosine of pi over 2 is radical 2 over 2 again. I know it's hard to write this out, so I'm just going to tell you. 2 times radical 2 over 2 is radical 2. And I'm left with 1 minus radical 2. Some of you might need a calculator, but you should know that radical 1 is 1. And do you agree radical 2 is bigger than radical 1? Or you can use a calculator. This is going to be a negative number. So on the left side I have a negative. On the right side I have a negative. So it looks like this. So this whole zone is positive. Okay. Now, positive. All right, pi over 2, so I'm running out of time. Let's go back to this one. Pi over 2, I'm going to get sine of pi over 2, going back to my unit circle. Here's pi over 2. Sine is 1. Sine is 1. Wonder if I messed this up. Sine of pi over 2 is 1. There's that negative out in front, which is negative. I get 1 minus 2 cosine pi over 2. Remember, pi over 2, cosine pi over 2 is 0. So this all just cancels. I get negative times a positive. And then negative times a positive is a negative. And the last one, I have 3 pi over 2. So I'll plug in 3 pi over 2 in here. Sine of 3 pi over 2 is negative 1. So that outside 1 becomes negative negative 1. I get a positive. And then in here, cosine of 3 pi over 2 is 0. And then I get 1 minus 0, which now becomes 1. So I get positive, positive, which means this whole zone is positive. Okay. Again, just follow along, write this down in your notes, and we'll practice on Thursday. But now, of my 3 critical numbers, 0, pi over 3, and pi, I need to say which one's a local min and which one's a local max. Well, at 0, do you see that it goes from a negative zone to a positive slope, or a negative slope to a positive slope? So if it goes from negative to positive, do I have a max or a min? Okay, I have a slope that goes from a negative to a positive, so I'm going to get a min. So min at 0. Okay. Now, from here, from this zone to this zone, I have positive to negative. That's a max, which means x equals pi over 3 is a max. And then lastly, I go from negative to positive. It's the same as 0. I have a min at x equals pi. So I hope you follow along pretty well. I know it's very complicated. I understand that we'll need some practice, but we'll see some more of these on Thursday, and we'll practice and play a game. Hope you enjoy your day off, and I'll see y'all on Thursday.